All right, let's start the second part here of 4.4. And before we had talked about combining or expanding logarithms. And this time we're going to talk about kind of word problems and the change of base formula. All right, so here, if a task is learned at a performance level P0, then after a time interval T, the performance level P satisfies. Okay, so they give you this formula where C is a constant that depends on the type of task and T is measured in months. So solve this thing for, solve this for P. So we're trying to isolate this P value. So we're going to kind of condense this so that maybe we can get one logarithm. Okay, so I'll come down here. And we notice that C is right here, so we can take this C to an exponent. So we have log P equals log of P naught minus log of T plus 1 to the C. Okay, now we have subtraction here. So I can combine those over division. So I have log of P equals log of P naught over T plus 1 to the C. And again, we don't need this C to be negative because that subtraction was already there. Now we have logarithms on both sides. So when you have the exact same logarithm on both sides, they do cancel. And if you were to rewrite it in exponential, you would see that they cancel. Or this logarithm has a base of 10. So if I take each side to the base of 10, that would cancel them as well. So we have P equals P naught over T plus 1 to the C. Okay, so that's part A. Part B says, for your score on a history test, if your score on a history test is 90, what score would you expect to get on a similar test after 2 months and after a year? Assume that C is 0.2. Okay, so we have after 2 months, and then a year is 12 months, because remember, T is in months. So here our P naught would be 90. So if we look up here, P0 is your task performance level, which was a 90. So we're looking for this P value right here. So I'm going to do one on this side and one on the other side. So 90 over 2 months plus 1, and then 0.2 is our C value that they gave us. And then the other one would be 90 over 12 plus 1 to the 0.2. And you can just do these in the calculator. And on this one, for 2 months, you're going to get a 72. And for this one, you're going to get a 54. Okay, and we kind of missed the title here at the top, but this is about the law of forgetting. So if you did nothing for your history test and you just 2 months went by, you would go from a 90 to a 72. In 1 year, you'd go from a 90 to a 54. Okay, you would forget some of that stuff. Okay, use a change of base formula and common or natural logs to evaluate each logarithm rounded to 5 decimals. Okay, like I said before, change of base formula used to be really important because I could not do a log base 8 or log base 9 into the calculator. I could only do a natural or a common log. So a change of base formula here is log of 5 over log of 8. The way I remember it is your big number goes on top, your little number goes on bottom. This is the same as ln of 5 over ln of 8. Or you could change it to anything. You could say log of base 5 of 5 over log base 5 of 8. Now, that doesn't really help you because you still don't know what log base 5 of 8 is. But up here, that could be a 1. And you can just manipulate these however you want. So if I type this on the calculator, if I just do ln of 5 over ln of 8, this goes to about 0.774. Okay, and here for log base 9 of 20, we can write this as log 20 over log 9, or that's ln of 20 over ln of 9, which either one goes to ln 20 over ln 9, 1.363 about. So we can change those bases however or whatever we want them to be. So graph using a graphing calculator. Now, again, we can do these different bases on our graphing calculators, but before they would want you to graph log base x or base 10 over log of 6. Okay. We've also talked about how we can create a table really quick using that different base. Okay, so base 6, so that's powers of 6. So that'd be 1 over 36, negative 2, 1 over 6, negative 1, 1, 0, 6, 1, 36, 2. Okay, so we don't necessarily need the graphic calculator for that. But if you want to type it in like this, you could. In order to, I'll go ahead and teach you this, but in order to graph any base or to input any base on our graphing calculator, let me kind of pull up my document camera here to show you. Okay, so on our graphing calculator here, if I hit alpha F2, see that F2 right there, or alpha window, I get a nice big menu right here with different things. And number 5 says log base, and it kind of gives you over here in blue. I know it's kind of hard to see on the screen, but over here in the blue, it kind of tells you what it looks like. So if I hit 5, now I can put in log base 6 of x, or any number I want, and hit enter. So when we go to y equals, we can say alpha window. We can go to number 5, and we can say 6 to the x, and then we can graph that. Okay, and that's kind of what it looks like. Again, this is just to check yourself, okay? You're still going to have to show the table. You're going to have to show work to get to that point, okay? All right, that is all for chapter 4.4. So if you have questions, reach out. If not, your assignment is on WebAssign.